In this class, we're going to go over questions on arithmetic progression. Okay, let's start with the first question. If the third term of an arithmetic progression is 14 and the sixth term is 29, find the 10th term of the sequence. Okay, let's start by writing out the information that we're given in the question. We are given that the third term of an arithmetic progression is 14. So T3 equals to 14. That is the third term. T3 represents the third term, you understand? Okay? And the sixth term is 29. So I'm going to represent the sixth term as T6, you understand? So I'm going to have T6 is equals to 29, okay? Now, we are asked to find the 10th term. I'm going to represent the 10th term as T10, you understand? So here, I'm going to have T10. We don't know the value of T10, you understand? So I'm going to represent it as, I just put question mark, okay? Now, we cannot determine the value of the 10th term without knowing the common difference and the first term of the arithmetic progression. Listen to the explanation again. To determine the 10th term, don't forget that the nth term for every arithmetic progression is what? Tn is equals to a plus n minus 1 multiplied by d. You understand? Now, if I want to get the T10, I'm going to have T10 is equals to a plus 10 minus 1 multiplied by d. Is that not it? So here I'm going to have T10 is equals to a plus 10 minus 1 is 9. You understand? 9 multiplied by d is what? 9d. So you can see that I cannot determine the value of the T10 without knowing the A, which is the first term, and the D, which is the common difference. You understand? So that means that I have to get the value of the first term and the common difference. Then when I'm done, I'm going to substitute it into this equation to get the 10th term. You understand? So I want you to pay attention. Now, to get the first term and the common difference, we've been given that the third term is what? Is 14, and the sixth term is what? Is 29. So here, I can use the formula for the nth term to derive a simultaneous linear equation. You understand? Just pay attention. T3 is equals to a plus n minus 1. N minus 1 now will be 3. N will be 3 now because I want to write an expression for the third term now. Are you paying attention? I want to write an expression for the third term with respect to the general formula for the nth term of an arithmetic progression. Okay, so here I'm going to have T3 is equals to a plus 3 minus 1 multiplied by d. Okay, T3 is equals to a plus 3 minus 1 is 2. So I'm going to have a plus 2d. Now we recall that T3 is equals to 14. You understand? So I'm going to have 14 is equals to a plus 2d. Okay, call this one equation 1. Okay, let's call this equation 1. Okay, now let's proceed to this is the first equation. Now, let's proceed to the second equation. How do we derive the second equation? The second equation can be derived from the sixth term. You understand? Don't forget that we'll be given that the sixth term is what? Is 29. So I'm going to have T6. The expression for the sixth term with respect to the arithmetic progression formula, the nth term of an arithmetic progression formula is T6 is equals to a plus 6 minus 1 multiplied by d. You understand? So T6 is equals to a plus 5d. Okay? Now, don't forget that the sixth term has been given as 29. So I'm going to have 29 is equals to a plus 5d. Okay? So this is equation 2. You understand? Okay? Now, we have two equations. The next thing is that I'm going to solve this equation simultaneously. You understand? I'm going to solve this equation simultaneously. So I want you to pay attention. Equation 1 is 14. Okay, 14. Okay, let's just write it. Let's rewrite the equation as this. A plus 2d equals to 14. Okay, that's the equation 1. Then equation 2, a plus 5d, a plus 5 equals to 29. Okay, 1, 2. Now, how do we solve this equation simultaneously? You see, in our previous class, we learned how to solve simultaneous equation, and I gave you two methods. The first is elimination method, and the second is substitution method. You can use any of this method to get the value of A and D, but in this video I'm going to be using the substitution method. Okay, so to get in an attempt to solve this equation using the substitution method, the first step is that you have to make one of the unknown the subject of the relation in any of the equation. Listen to the explanation again. How many equations do we have? We are having two equations. How many unknown do we have? Unknown simply means the terms that we don't know. You understand? The terms that we don't know in our equation is what I call unknown. You understand? Now, we have A and D. Those are the two unknowns that we don't know in the two equations. You understand? The values of A and D is what we want to determine. So we don't know it. You understand? That is why I call them unknown. You understand? Okay? Now, here, the first step is that you have to make one of the unknown the subject of the relation in any of the equations. So I'm going to make A the subject of the relation in the first equation. You can choose any equation of your choice, you understand? But here I'm going to be using equation 1. I'm going to make A the subject of the formula or subject of the relation, okay? Equation 1 is what? A plus 2D. A plus 2D equals to 14. So I'm going to make A the subject of the relation. To make A the subject of the relation, I'm going to take this plus 2D to the right hand side of the equation, okay? The right hand side of the equation only contains 14. The left hand side contains A plus 2D. Now, because I want A to stand alone, I want to make A the subject of the formula, I'm going to take this plus 2D to the other side of the equation. So it becomes A is equals to 14 minus 2D. You understand? So that is the first step, okay? I make one of the unknown the subject of the relation in any of the equation. Here, I choose equation 1, then I make A the subject of the relation. Now, the second step is that you have to substitute the value of A into the second equation. I'm going to explain. Listen. This equation contains two unknowns, you understand? But in solving this using the substitution method, the first step is that you have to make one of the unknown the subject of the relation. So I make A the subject of the formula in equation 1. I'm not going to substitute that value of A in equation 1 again. You understand? I'm going to substitute that value of A into equation 2. Listen, if you substitute that value of A into equation 1, you won't get the right answer, okay? So if I make A the subject of the relation in equation 1, I'm going to substitute that values into equation 2, okay? So since I make A the subject of the relation in equation 1, equation 2 is what? A plus 5D equals to 29. So I'm going to substitute A as 14 minus 2D into equation 2. Okay? So here I'm going to have, please listen, I'm going to have this. Since A equals to 14 minus 2D, I'm going to have 14 minus 2D plus 5D equals to 29. Do you know what I did? I replaced A as 14 minus 2D. So I have 14 minus 2D plus 5D equals to 29. Do you understand? Okay? Now, 14 minus 2D plus 5D. You are owing someone 2 naira. You are having 5 naira. If you pay the 5 naira, that means you are going to collect change. That change is 3 naira. Now, we have negative 2D, which is minus 2D, plus 5D. That is what? Plus 3D, which is equals to 29. Okay? So we have 3D is equals to 29 minus 14. Okay? Now, 3D is equals to 29 minus 14. That is 15. So I'm going to have 3D is equals to 15. Divide both sides by 3 to get the value of D. So here I'm going to have D is equals to 5. Okay? So I've gotten the value of D as 5. Now, don't forget that the goal is to determine the value of A and D. Okay? So having gotten the value of D as 5, I can get the value of A by substituting the value of D into this equation. Okay? Don't forget that in equation 1, A is equals to 14 minus 2D. You understand? So when D is equals to 5, I'm going to have A equals to 14 minus 2 multiplied by 5. Okay? All I did is that I just replaced the value of D as 5. You understand? So here, I'm going to have, this is not 9, it is A. A equals to 14 minus 10. You understand? Because negative 2 multiplied by 5 will give us negative 10. Okay? So here I'm going to have A equals to 4. So the value of A and D is 4 and 5 respectively. Now, having gotten the value of a and d, we can go back to this and substitute to get the 10th term. You understand? So the 10th term will be equals to a. A is 4, so I'm going to have 4 plus 9 multiplied by d. D is 5, so I'm going to have multiplied by 5. So T10 will be equals to 4 plus 5 multiplied by 9. That is what? 45. So here I'm going to have plus 45. So the 10th term is equals to 45 plus 4 is 49. So that is the solution to that question. Okay? So I'm very sure you understood how I got this. If you have any question, let me know in the comment section, okay? Now, let's proceed to the second question. How many terms has the AP whose first term is 15 and the last term is 57, given that the common difference is 3? Okay? Look at that question. Okay? Let's start by writing out the information that we're given in the question. Whereas the question says, how many times has the AP whose first term is 15? So, what the first parameters that were given in the question is the first term. And the first term is represented as A. So, I'm going to have A equals to 15. Okay? And the last term is 57, the last term. Let us represent the last term as L. Okay? So, L is equals to 57. Okay? And the common difference is 3. So, the common difference is 3. Okay? So, now, listen. Let me give you an example. You understand? Suppose we have a sequence. Okay, please pay attention. Suppose we have a sequence that contains the following number: 1, 2, 3, 4, 5, 6, 7. Okay? Now, let's say this is a sequence. Now, in this sequence, the first term is what? The first term is 1, which is A. The second term is what? Is 2, which is what? T2. The third term is what? 3, that is T3. The fourth term is what? T4. The fifth term is 5, which is T5. The sixth term is T6. The seventh term is T7. Now, in this sequence, the last term is what? Is the seventh term. You understand? Now, that seventh term, what is the numbers of terms that is contained in this sequence? The numbers of terms is 7. You understand? Are you paying attention? I'm going to give you another example. Let's say we have the following sequence: 2, 4, 6, 8, 9, 10, and 12. Okay? How many terms does this sequence have? This sequence has 1, 2, 3, 4, 5, 6, 7. 7 terms. You understand? So, listen. What I'm trying to drive out is that the term, the numbers that is accrued to the last term will be the numbers of terms that is contained in the sequence. You understand? Listen. The numbers that is allotted to the last term will be the numbers of terms that the sequence is going to contain. This is the first term. This is the second term, T2. This is the fourth term. This is third term, sorry. This is the fourth term. This is the fifth term. This is the sixth term. This is the seventh term. You understand? Now, how many terms does this sequence contain? It contains 7. You understand? So, the last term gave us the idea of the numbers of terms that the sequence contains. Do you understand? Now, let's go back to the question. We are given that the last term is what? Is 57. Okay? The values is different from the position. You understand? With respect to the position, this is the 7th term. You understand? But the values of the 7th term is what? Is 12. Listen, I don't want to get confused. Okay? Listen. The 7th term, the position is what we call term. The values of that term is different from the position. You understand? For example, T6 is the position, you understand? That is the sixth position, you understand? Sixth term. Now, the values of the numbers that is present in the sixth term is what? Is 10, you understand? Because I told you in our previous class that terms represent the position where our values stand, you understand? Where the individual number that is contained in the sequence stand. That is what we call term, you understand? So, the seventh term is what? Is 12, okay? So, don't say that because the seventh term is 12, the sequence contains 12 number. No, you will miss it, okay? The last term is the seventh term, and the seventh term is 12. The sequence contains 7 numbers. You understand? How many? It contains 7 terms. Now, let's go back to the question. The last term, the value for the last term is what? 57. Okay? Now, to get the numbers of terms that the sequence contains, we are going to use the last term. You understand? We are going to use this value. Just pay attention. Recall that the nth term for an arithmetic progression is given by this formula. Tn is equals to a plus n minus 1 multiplied by d. Okay? Now, because we've been given the last term is what? 57. So I'm going to replace Tn by 57. So I'm going to have 57 equals to a plus, I don't know the value of n, so I'm going to leave it, n minus 1 multiplied by d. Are you paying attention? Recall that a and d is what? 15. A is 15 and d is 3. So I'm going to have 57 is equals to 15 plus n minus 1 multiplied by 3, because d is 3. So 57 is equals to 15 plus n 3 multiplied by n, that is 3n. Negative 1 multiplied by 3, that is negative 3, okay? So 57 is equals to 15 minus 3 is 12. So I'm going to have 12 plus 3n. Now, I'm going to collect like terms. 57 minus 12 is equals to 3n, okay? 57 minus 12 is 45, okay? So I'm going to have 45 is equals to 3n. So to get the value of n, you see, the numbers of terms that this sequence contains is n. You understand? Okay? So I'm going to divide both sides by 3. So this divided by 3, this divided by 3. N is equals to 9. Okay? So this sequence contains 9 terms. You understand? Please, I don't know, maybe you get the I don't know, maybe you get the idea behind the solution to this question. That means that the T9 is what? The T9 is 57. You understand? Which is the last term. Do you understand what I'm saying? Okay, the T9, the ninth term is 57. So the sequence contains 9 terms. You understand? Hello, listen. The ninth term is 57. Hence, the sequence contains 9 terms. You understand? The total numbers of terms that is present in the sequence is called 9. You understand? But the ninth term of that sequence is what? 57. Okay? So the solution to that question is 9. Okay? That is the total numbers of terms that is present in the sequence. Okay? So that will be all for this class. If you have any question with respect to what we've learned in this class, let me know in the comment section. Okay? See you in the next class.